Hi, today our article's topic belongs to futuristic technology with a belief that you would like the article. So let's begin. Nuclear-powered aircraft. A vision for sustainable aviation. As the world grapples with the challenges of climate change and seeks sustainable alternatives across various industries, the aviation sector is under increasing pressure to reduce its environmental footprint. In this quest for greener solutions, nuclear-powered aircraft have emerged as a visionary concept. The immense energy potential of nuclear power, these aircraft have the potential to revolutionize air travel and pave the way for a more sustainable future. This article explores the concept of nuclear-powered aircraft, highlighting their potential benefits, challenges, and the current state of development. The promise of nuclear-powered aircraft. Unprecedented range and endurance. The promise of nuclear-powered aircraft represents a groundbreaking vision for the future of aviation. By harnessing the immense energy potential of nuclear power, these aircraft offer a range of compelling advantages. Firstly, nuclear-powered aircraft boast virtually unlimited range and endurance. Unlike conventional aircraft that rely on fossil fuels and require frequent refueling, nuclear reactors provide a continuous and abundant source of power, enabling long-haul flights without the need for refueling stops. Moreover, nuclear-powered aircraft have the potential to significantly reduce the environmental impact of aviation. By replacing conventional jet engines with nuclear reactors, carbon emissions can be drastically reduced or even eliminated. This aligns with global efforts to combat climate change and achieve carbon neutrality. Secondly, the efficiency of nuclear-powered aircraft is also a notable advantage. With higher energy density compared to traditional aviation fuels, these aircraft can achieve higher speeds and improved overall performance. Shorter flight times, increased passenger capacity, and enhanced productivity are all potential benefits that could transform the air travel experience. However, it is important to acknowledge the challenges and limitations associated with nuclear-powered aircraft. Safety concerns, regulatory hurdles, and technological complexity must be addressed before these aircraft become a reality. Ensuring the safe operation and containment of nuclear reactors within an aircraft, establishing robust regulations, and overcoming technical obstacles are critical steps in the path towards nuclear-powered aviation. While no fully operational nuclear-powered aircraft has yet taken to the skies, ongoing research and innovation in nuclear and aerospace technologies hold the potential to bring this visionary concept to fruition. By addressing the challenges and advancing our understanding of nuclear-powered aviation, we can unlock a future where air travel is not only sustainable but also offers unprecedented capabilities. The promise of nuclear-powered aircraft offers a glimpse into a future where long-range, emission-free flights are a reality, revolutionizing the way we travel and paving the way for a greener aviation industry. Enhanced efficiency. Nuclear power offers a higher energy density compared to traditional aviation fuels, enabling nuclear-powered aircraft to achieve higher speeds and greater efficiency. This could result in shorter flight times, increased passenger capacity, and improved overall performance, thereby enhancing the efficiency and productivity of air travel. Challenges and limitations. Nuclear-powered aircraft raise valid safety concerns due to the potential risks associated with nuclear technology. The safe operation and containment of nuclear reactors within an aircraft present significant engineering challenges. Ensuring the integrity of the reactor and shielding passengers and crew from radiation are critical considerations that need to be addressed for the development of a viable nuclear-powered aircraft. Regulatory hurdles. Introducing nuclear-powered aircraft into commercial aviation would require a robust regulatory framework to address safety, security, and environmental concerns. International cooperation and agreements would be essential to establish uniform standards and regulations governing the use of nuclear power in aviation. Technological complexity. Developing nuclear-powered aircraft is a complex engineering endeavor. Overcoming technical challenges related to the miniaturization and efficient operation of nuclear reactors within the confined space of an aircraft remains a significant obstacle. Moreover, the development of advanced propulsion systems capable of harnessing the energy generated by nuclear reactors requires extensive research and innovation. Current state of development. While no fully operational nuclear-powered aircraft has yet taken to the skies, there have been notable research initiatives and prototypes. Experimental projects such as the Convair X-6, NB-36H Crusader, and Tupolev Tu-119 explored the feasibility of nuclear-powered aviation during the mid-20th century. More recent concepts, such as the direct energy conversion and nuclear thermophotovoltaics, have sought to overcome some of the technical challenges associated with traditional nuclear reactors. Nuclear-powered aircraft represent a compelling vision for the future of aviation, offering the potential for unlimited range, reduced environmental impact, and enhanced efficiency. However, numerous challenges, including safety concerns, regulatory hurdles, and technological complexity, must be addressed before these aircraft become a reality. As research and innovation in nuclear and aerospace technologies continue to advance, nuclear-powered aircraft may find their place as a sustainable and efficient mode of air travel, shaping the future of aviation and contributing to a greener planet. Exploring the potential. A list of nuclear-powered aircraft. The world of aviation has witnessed remarkable advancements over the years, with constant innovations aimed at enhancing efficiency, range, and sustainability. One intriguing concept that has captured the imaginations of engineers and aviation enthusiasts alike is nuclear-powered aircraft. By harnessing the immense energy potential of nuclear power, these aircraft could potentially revolutionize air travel. This article aims to present a comprehensive list of nuclear-powered aircraft designs that have been explored or proposed throughout history. Convair X-6. One of the earliest nuclear-powered aircraft concepts, the Convair X-6 was designed in the 1950s as part of the United States Air Force's Nuclear Energy for the Propulsion of Aircraft (NEPA) program. It was envisioned as a strategic bomber capable of flying intercontinental distances without refueling. However, the project was ultimately cancelled due to concerns over safety, feasibility, and cost. NB-36H Crusader. The NB-36H Crusader was an experimental aircraft developed by the United States during the Cold War era. It was a modified version of the B-36 bomber, equipped with an operational nuclear reactor. The reactor powered a heat exchanger, which in turn drove the aircraft's turboprop engines. Although the NB-36H successfully completed a series of test flights, the project was eventually terminated due to safety concerns and the advent of more efficient jet engines. Tupolev Tu-119. During the 1960s, the Soviet Union explored the idea of nuclear-powered aviation with the Tupolev Tu-119. It was essentially a modified Tu-95 strategic bomber, equipped with a nuclear reactor. The reactor provided power for both propulsion and onboard systems. However, the Tu-119 never flew with an operational reactor and was used solely for ground testing purposes. Project Pluto. Project Pluto was a highly ambitious and unconventional American endeavor in the 1960s. It aimed to create a nuclear-powered, unmanned cruise missile capable of delivering nuclear warheads. The missile, known as SLAM, Supersonic Low-Altitude Missile, utilized a nuclear-powered ramjet engine. Despite successful ground tests, the project was ultimately abandoned due to concerns over safety, environmental impact, and the evolution of intercontinental ballistic missile technology. Mikoyan-Gurevich MiG-105. The Mikoyan-Gurevich MiG-105, also known as the Spiral, was a Soviet experimental spaceplane developed during the 1960s and 1970s. It featured a unique lifting body design and was intended to be launched vertically using rocket boosters. The spacecraft's propulsion system was proposed to include a combination of liquid hydrogen and a nuclear-powered ramjet engine. However, the nuclear-powered variant of the MiG-105 never progressed beyond the initial design stage. Project Orion. Project Orion, conceived in the late 1950s, was a groundbreaking proposal for a nuclear-powered spacecraft rather than a conventional aircraft. It aimed to utilize nuclear explosions for propulsion by detonating small nuclear bombs behind the spacecraft. The force generated from the explosions would propel the spacecraft forward. Although the concept was highly innovative, it was never fully developed due to international treaties banning nuclear explosions in space. Bussard Ramjet. The Bussard Ramjet, named after physicist Robert W. Bussard was a concept proposed in the 1960s for an interstellar spacecraft. While not a conventional aircraft, the Bussard Ramjet concept involved using a large electromagnetic field to collect interstellar hydrogen as fuel. A nuclear fusion reactor would then heat the collected hydrogen, creating thrust for propulsion. Despite its potential, significant technological challenges and feasibility concerns have prevented the realization of a functioning Bussard Ramjet. Dassault Mirage 4000N. In the 1980s, France explored the idea of a nuclear-powered variant of the Dassault Mirage 4000 fighter aircraft. The proposed design involved incorporating a compact nuclear reactor to provide propulsion and electricity for onboard systems. However, the Mirage 4000N project did not advance beyond the conceptual stage, as the practical challenges associated with nuclear reactors on board fighter jets posed significant safety and operational concerns. Project Pluto II. Project Pluto II was a revival of the original Project Pluto concept mentioned earlier. In the 2000s, the United States revisited the idea of nuclear-powered propulsion for a supersonic cruise missile. The project aimed to develop a compact nuclear reactor that would power an air-breathing scramjet engine, offering extended range and endurance. However, the project was cancelled due to shifting priorities and the inherent complexities involved in deploying nuclear technologies in military applications. Future prospects. The concept of nuclear-powered aircraft has captivated engineers and aviation enthusiasts for decades, representing a potential leap forward in the evolution of air travel. While several designs and prototypes have been explored, no fully operational nuclear-powered aircraft has ever taken to the skies. Challenges related to safety, environmental concerns, and cost-effectiveness have impeded the realization of these ambitious projects. Nevertheless, the research and development efforts in this area have contributed to the advancement of other aerospace technologies and continue to inspire future generations of engineers to push the boundaries of aviation innovation. We hope you have enjoyed the article which is proposed for the future endeavor. Please watch, subscribe and comment.